Welcome everyone to tonight's Tech Talk with Imma D. She will be presenting on microservices. Take it away, Imma.
Good evening, everyone. My name is Imma D, and tonight I will be speaking about microservices. Before I get started, I would like to thank Jeannie and Bracklet for sponsoring this Tech Talk. Now, what are microservices? In short, microservices refer to an architectural approach for developing applications. An application is comprised of smaller independent parts or services. Each are responsible for maintaining a small business of business functionality and data management. Before I expand on the significance of microservice architecture, we'll first need to discuss the popular method of designing applications prior to the microservice approach. For the purposes of this talk, I will be speaking about two different application architectural styles. First, I will begin by explaining what a monolithic application architecture is, along with its associated challenges, using Shopify as a case study. Then I will delve deeper into the microservice architecture style and discuss its design principles. I will also discuss the various benefits and drawbacks of this style. Finally, I will discuss Netflix's migration from a monolithic to a microservice application. Oh, am I going back? Okay, so monolithic architecture. Prior to microservices, the standard method of developing applications was with a monolithic architecture. The most important aspect of this is that components reside in a single code base and are deployed as a single file. A great example of monolithic applications is an e-commerce platform where user profiles, comment threads, and post management and all other functions are interdependent, managed in one place, and stored in a single database. To highlight overall benefits and challenges that come with monolithic architecture, I'd like to highlight Shopify as a case study. Shopify, one of the leading e-commerce platforms, was initially built as a single process monolith in Ruby on Rails. This meant that the majority of Shopify's distinct functionality, like handling shipping, updating products, and billing merchants, were built into the same code base with little to no boundaries in between them and were deployed as a single process. Over time, this resulted in tight coupling between code that handled different business functionalities. In order to visualize tight coupling, think of a class that calls an internal function of another class. An altercation to class 2's internal data can inadvertently impact the expected result of class 1's invoked method. Monolithic applications are the benefits of monolithic applications are many, but in this case, I'll be talking about 3. So monolithic applications are simpler to develop. Shopify developers only need to maintain one code base or one repository and are able to easily search for all relevant functionality in a single repo. Data lives in a single and shared code database, leading to easier data management and maintenance of data consistency. They're also simpler to deploy, meaning teams only have to maintain one test and deployment pipeline. Now, scaling is starred because this is both a pro and a con for monolithic applications. For smaller applications, we can scale the application by running multiple copies behind a load balancer to distribute requests across the different servers. However, Shopify eventually outgrew its monolithic architecture as it became increasingly more difficult to roll out and build new features. Now, there are significant challenges in scaling, like I mentioned before. So in a monolithic architecture, you usually only scale loosely coupled components with the highest demand. You wouldn't want to scale parts of the applications that are used significantly less. In Shopify's case, the components we'd be most interested in scaling would be product information, the shopping cart, and payment services, since they're more frequently used. However, these functionalities within the Shopify's monolithic code base are tightly coupled. Different components may have different resource requirements. One may be CPU intensive, the other more memory intensive. So running more copies of the application means a higher infrastructure cost overall. These applications can also get too large and complex over time. In Shopify's case, onboarding new developers was a challenge. Since the business logic was tightly coupled, a new developer joining the shipping team would also need to discover understand payment processing and order creation, leading to steeper learning curves when onboarding a new dev. It also meant that a single change in the code base could trigger a cascade of unrelated test failures. So for example, logic for calculating shipping and tax rates were tightly coupled. So changing one could result in an inaccurate calculation of the other. And also a bug in one module can bring down the entire application. As for continuous deployment, in order to introduce any updates to a singular component, we would have to redeploy the entire app. This in turn discourages frequent updates. As a result, teams working on different functionalities like UI and inventory, etc., must now coordinate their development efforts and their deployments. Also, incorporating new technology can be really challenging. So when Shopify originally started in 2006, they're pretty much stuck with Ruby on Rails. And because of this, it can be incredibly expensive to rewrite all the components of a monolithic application using newer frameworks and libraries. So developers working with this code base are bound to the tech stack that was initially chosen at the start 16 years ago, which can present a problem as the application gets larger. If one wants to incorporate a new functionality, you have to take into account that original tech stack when determining what tools to build out your component. Now, switching over to microservices, I'd like us to keep the Shopify example in mind because I'm not going to reveal quite yet how they chose to evolve their single process monolith. So once again, microservices is an approach to developing a single application as a suite of small services, typically built around one aspect of business functionality. Services are typically deployed, developed, and scaled separately. This ensures that they are loosely coupled, meaning that one change to one service will not impact another. In this image, in a monolithic pattern, the individual components and all functionality for these components exists in one code base and is encapsulated in a container and deployed as a single unit. In contrast, the microservice style is divided by different business functionalities, encapsulated in their own containers and independently deployed. I'll now discuss the 5 principal designs of microservice architecture. Okay, number 1, we must organize around business capabilities. So services are split into individual business functionality. For example, a shipping service response should be solely responsible with shipping and have nothing to do with account management operations. Each service should perform their one functionality well. So these should be entirely unique to its own functionality. Number 2 and 3, discrete boundaries and transportability. So services must be well encapsulated and all logic and data relevant to a single concern must be encapsulated in that single deployment unit. Services should also be able to move from one runtime environment to another with little effort. Microservices will use containerization tools like Docker, which bundles any libraries, dependencies, and configurations required to make the service run, regardless of an independent developer's runtime environments or operating system, making services easily transportable from one local machine to the next. Number 4, design for microservice failure. So microservice teams constantly keep in mind how service failures affect user experience. Therefore, the design of the service should be such that even if a single service is down, the application should continue to function and recover gracefully from that failure with minimal effort. Okay, number 5, decentralized data management. While monolithic applications prefer a single database for persistent data, in a microservice app, each service has its own database and can choose the database best suited to its needs, usually resulting in polyglot persistence. So for example, this service might use a NoSQL database to best handle their data, while this might use a SQL database. Now I'd like to talk about the API gateway pattern very briefly. So this image is an example of that. So with this pattern, the gateway service usually serves as the single entry point into the system for all clients. This typically insulates the internal microservice architecture from the clients. So without a gateway, users would be able to directly communicate with the service. So just ignore this middle section and imagine all of these arrows going to various services for various requests, right? And without this gateway, users would be able, well, with this happening, essentially like services can be built on different web protocols or different protocols that may not be friendly to the client's web surface. So requests are then routed to the appropriate service or fanned out to multiple services depending on the nature of the client's requests. The gateway can also aggregate the data requested from the individual service into one and return it to the client. Because the gateway handles the client request in a centralized manner, it is usually considered best practice to implement cross-cutting functionalities such as authorization, authentication, load balancing, and many others. So this essentially abstracts a lot of the logic and data into one service. However, using the gateway pattern also introduces the possibility of a single point of failure should this API gateway go down. And it also adds further complexity because it's another component of the larger application that must be developed, deployed, and managed. So I'll now discuss the various benefits of microservices. Number one, scaling. The modularity of microservice architecture means that services can be scaled independently of one another. Netflix, for example, can scale services that run video streaming functionality on the weekends, since developers can anticipate higher user traffic during those times. In comparison, recall that in a monolithic architecture, the entire application is typically scaled, since it's difficult to piece out the different business logics in a monolithic application. Number two, autonomous development and cross-functional teams. If an application requires more than 500 independent services, and believe me, they can, each of these modules can be developed by an independent team of developers at the same time. And cross-functional teams are necessary because you'll have one person or several who can work on UI, others who can work on the middleware logic, others who can work on database management, et cetera, right? Number three, deployment. So if there is an update in one of the microservices, then we only need to redeploy that one microservice. Now recall in monolithic architecture, you would have to redeploy the entire application. Number four, improved fault isolation. Because of the design for failure principle, if one service crashes, the rest of the application can continue to operate until it recovers. In a monolithic application, a fault in a single component has the capacity to bring the entire application down. Number five, better onboarding. New developers only need to understand the functionality of the microservice they're currently working on and not the entire system. And number six, no long-term commitments to a tech stack, which is fantastic because developers can select their desired technology based on the business capabilities of that service, meaning that one can leverage a Node.js backend while maintaining a NoSQL database, while another service can use Python and SQL. As for the drawbacks of microservice architecture, there are quite a few. It is very nuanced, but I'll cover the most important ones. So number one, communication between services can be very complex. Developers must account for the communication mechanism between each individual microservice. The two most common communication types are synchronous protocols. This is typically HTTP. So clients send a request to the service and their service sends back a response. There's also asynchronous messaging protocol using message brokers like RabbitMQ for communication between microservices. Message brokers usually collect a queue of these messages and distribute them to its corresponding service. Microservice applications typically use a combination of both synchronous and asynchronous methods of communication, so you'll have to account for both, meaning that writing this out can be very difficult for developers. Number two, database management. Earlier, I talked about decentralized database management as one of the design principles of microservices. This typically leads to an eventual data consistency, which guarantees consistency throughout the entire application, but not at all times, which means that developers must best coordinate will have to manage how to coordinate these local transactions to make sure that everything is eventually consistent. Testing. Okay, so microservices are difficult to test as a whole. You typically can't run a single microservice to test its web services without having to run a mock of all of its other associated services, which can be really challenging to develop. And then number four, deployment complexity. And because these services are written using a myriad of languages and frameworks and framework versions, each one of them has their own specific deployment and monitoring requirements. Also, refactoring one service also can possibly mean refactoring dependent services and coordinating their deployments as well. Excuse me. Now that I've reviewed both monolithic and microservice architecture in depth, along with their respective benefits and drawbacks, I'd like us to think back to Shopify's 2016 predicament when determining how they wish to evolve their tightly coupled monolithic code base. It's imperative to note that neither one of these architectural styles are inherently better than the other. They have their separate benefits based on the unique demands of the application's functionality. Okay, so keeping in mind the challenges presented by microservice architecture, Shopify ultimately chose to evolve their code base into a modular monolith as opposed to the microservice pattern. This was a happy medium between both styles, specifically because Shopify wanted to prioritize modularity without increasing the number of deployed units. So they opted for an architecture that allows developers to work on the modules independently, but can still be combined together for deployment, meaning that the application would still be deployed as a single unit. Ultimately, they sought to break up the core monoliths into these smaller components, reorganizing the monolith by business functionality, hoping that it would highlight areas of code that were tightly coupled. And if you're interested, I highly recommend you check out Shopify's engineering blog to learn more about how they did that. I will now talk about Netflix as a contrast because it's a really interesting story. So Netflix started off as a monolithic application, but they ended up pioneering the migration into microservices. They were encouraged to adapt their application architecture after they suffered a massive database corruption due to a single mistake in 2008, and consequently had to shut down for 3 days because they couldn't ship out DVDs to customers. As a result, they wanted to shift away from vertically scaling their relational databases, which for them were more susceptible to single points of failure. They shifted instead towards horizontally scalable distributed systems in the cloud in order to mitigate the risk of database failure. They also needed to up the scale of individual services whenever the demand increased for that particular functionality. Excuse me. They ultimately decided on Amazon Web Services as their cloud provider since it gave them the greatest scale and broadest set of services and features. It took them 7 years to complete their full migration to the cloud. This in turn encouraged them to break down their monolithic legacy application into smaller individual microservices. And in doing so, they developed an agile development pipeline where many developers can deploy smaller changes into production over the course of a day. Pardon me. So Netflix adopted microservice architecture to design an efficient video streaming system with its high availability and scalability to serve 223 million subscribers. And that was pulled, I think, as of October of this year. Okay, in summary, microservice architecture is based on a modular approach, meaning that the application is divided into smaller parts. Microservices have become increasingly popular over the years due to its scalability, flexibility, and reliability. Here are the resources that I used to prepare for my tech talk. I highly recommend Sam Newman's book and the Shopify engineering blog in order to learn about their transition from a single process monolith to a modular one. I also recommend you check out Netflix's blog as well, because that was pretty interesting. Okay, that concludes my tech talk. Thank you for attending, and please contact me if you have any more questions or would like to talk about anything more in depth. Thank you.
Thank you, Imma. Let's give her a round of applause.
Yay! Nice job, Imma.
And it looks like we do not have any time for questions. So thank you again, Imma, and thank you everyone for coming.